Hi, my name is Allie Hypes, and I'll be presenting on the informal recycling of used lead-acid batteries, which is a global environmental health issue. This presentation will focus on the potential for interprofessional collaboration and intervention design.
Here is the outline of what we'll cover in this presentation. The objectives of this presentation are to understand the problem of global lead-acid battery recycling, examine the pathways of exposure, consider levels of intervention, and learn how interprofessional problem solving can be a useful tool for assessing and mitigating global health issues. Invented in 1859, the lead-acid battery was the first rechargeable battery sold for commercial use. Today, lead-acid batteries account for 86% of the total global consumption of lead. As economic development progresses across the world, the demand for vehicles and by extension lead-acid batteries is expected to increase exponentially. Between 2000 and 2018, the number of new vehicles sold in low to middle income countries more than tripled. A used lead-acid battery is one where its lead plate has deteriorated and no longer generates energy, at which point it is ready to be recycled. The three main components of a lead-acid battery, which make it so recyclable, are the insulating plastic, the sulfuric acid electrolyte, and of course the lead, which accounts for 64% of the battery's material. Lead-acid battery recycling is compatible with a circular economy, as it can be indefinitely recycled with little to no reduction in the quality. Secondary lead is known to be as good as the metal obtained from mining. As you can see, this is a major global market, which is on the rise due to the continued electronic waste exportation from wealthy countries, despite international laws forbidding it. The UN estimated that 10 to 40% of the United States e-waste is still exported. Informal recycling is a symptom of poverty. Low to middle income countries which receive exported e-waste and experience poorly regulated disposal methods in their own countries have entire communities exposed to and making use of the waste.
The main pathways for lead poisoning are through inhalation and ingestion. Almost all components of a lead-acid battery are recyclable, the main three of which are points for potential contamination in the process of recycling if handled improperly. The lead smelting and refining process produces fumes which can be inhaled. The sulfuric acid is often disposed by draining it into the soil or nearby bodies of water, which can poison people who eat the fish from the waters or crops from the contaminated soil, as well as those who use it for drinking water or bathing. The plastic components are often burned or shredded, both of which can expose people to inhaling or even ingesting fine plastic particles. As you can see, the entire process of informal recycling poses a great risk to the environment and human health. The intervention methodology I posed to each of the chosen professionals gave them an outline of what potential strategies I identified for addressing informal lead-acid battery recycling. Their responses and contributions will serve to highlight what can be included or changed in this public health lens. Each professional provided an enriched perspective on this methodology, the combined effect of which will be seen later on. 3 intervention strategies were devised through analyzing the CDC's level of controls and leverage points. Strategy A focuses on more proximal solutions to exposure with a community-level approach. Strategy B is more structural and emphasizes governmental controls. Strategy C is the most distal and upstream solution, which focuses on changing the battery itself.
The first professional I interviewed was Corey Hypes, the Vice President and General Manager of Integrated Solutions at Duravant. As a professional in the field of automation, Corey's approach to this issue emphasized corporate social responsibility. With a distinctly operational perspective, Corey pointed out that the informal recycling sector is an opportunity for economic growth and an unutilized workforce. The case of informal recycling of used lead-acid batteries is to Corey a microcosm of a wider structural issue of outsourced labor and workers' rights. The implementations Corey recommended were to 1. Provide the informal sector with government subsidies on the condition of basic health and safety requirements, to promote safe competition while legitimizing the market of recyclers to improve working conditions without eliminating their source of income. And 2, to create stronger regulations of global e-waste enforce buyback schemes to hold companies accountable for the management of their product's lifespan. As a debt finance lawyer, Rory's work often involves supporting loans to healthcare companies. Her professional perspective supported an understanding of the financial motivations of companies. In this way, Rory took a practical stance when considering ways to realistically address the issue of informal lead-acid battery recycling. We discussed how public-private partnerships would be key to successful regulation. She remarked that in all negotiations, the objective is to make everyone feel that they've won in some way. The recyclers, sellers, and manufacturers are more likely to comply with regulations if they see that doing so is in their best interest. This led us towards the importance of cost-benefit analysis, as it's crucial to note that according to the WHO, the economic cost attributable to the effects of lead on intellectual development of children are estimated to be 1.2% of global GDP. Rory believes that the strongest strategy is to redesign a battery to start from the source of the problem. While the research and development of new batteries is underway, the environmental impact and health effects of the informal sectors around the world must be monitored by collecting data on the number of informal recyclers, the impact on the communities, and gathering evidence of what methods to mitigating the problem at the point of recycling have worked. This evidence and innovation motivates governmental and private cooperation as not an expense, but an investment with long-term benefits for both monetary returns and the protection of environmental and human health. As a lawyer and commissioner of the DuPage County Board in Illinois, Julie regarded public awareness and advocacy as crucial components to addressing environmental health issues. She remarked that regulation is nothing without enforcement, and that we should be asking who is benefiting from the cause of this major public health issue. The objective is then to hold them accountable and, as in the case of Sterigenics, expose the benefactors for their negligence. Julie emphasized that we should not underestimate the power of publicity to put pressure on companies, governments, and global agencies to rectify this international problem. She believes that education and social movements are powerful motivators and catalysts for change. She argues that with the support of the public and shared outrage over this injustice, change is bound to unfold. The interprofessional approach to the original methodology framework is now a three-pronged approach. Julie's ideas and expertise in local government have been used to change Strategy A into a social movement where both affected communities and global populations are empowered to take action. Strategy A thus uses public awareness and advocacy to motivate community-level public safety campaigns and raise international support for this intervention. Strategy B, according to Corey's Automation's perspective, works with corporate social responsibility, battery life cycle management through buyback schemes, and promoting economic growth through fair market competition. Finally, Strategy C, Rory's background in law added public-private partnerships as well as research and development towards innovative, sustainable solutions through both battery design and data collection. Challenges to this project would include funding, enforcement, compliance, and sustainability, all of which are a part of any initiative. This approach would address the problem of informal lead-acid battery recycling from diverse vantage points, utilizing the interprofessional perspectives to implement social, commercial, and financial drivers for change.